Hey everybody. This is the last section of Chapter 3. It's actually called Additional Topics, but in reality it's about learning about permutations and commutations and the counting techniques that come with them, which we'll be using when we compute probabilities. So, again, I'm breaking this video into two halves, so this is the first half. And the first thing is that about combinations and permutations. It's largely more important instead of what they are is how they're different. So a permutation is an arrangement of objects, and the combination is a set of objects. And the thing to remember is, with permutations, order matters, and with combinations, it doesn't. Okay. The way we do this is to count out the number of permutations and combinations in certain situations. We have to use this thing called factorials, and maybe you've heard of it. If n is a positive integer, n factorial is just defined as the product of the first n positive integers, right? All the integers from 1 to n multiplied together. So that's defined as n followed by an exclamation point. And then as a sort of a degenerate case, we have 0 factorial. It's just defined to be 1. And we'll see why that is a little bit later. It just makes our formulas work that much nicely. So the first formula we want to know is how many ways can we arrange n objects? So they assume these objects are all distinct, okay? How many ways can we arrange them, let's say, in a line? Well, it's n factorial. And the reason for that is we're using the general multiplication principle, where we know where we define to do say n tasks in succession. We first count the number of ways to do the first task, then count the number of ways to do the second, and so on, and then multiply them together. So to arrange them, we first pick the first object, and there are n ways to pick the first object. And then after that, there are n minus 1 choices for the second object. And n minus 2 ways to pick the third object. And all the way down until there's only one way to pick the last object, or the nth object. Okay, so we use the multiplication principle, and we multiply all these numbers together, which is precisely what n factorial is. Okay, all right. So that's one formula you need to know. Another one is there are some times where you're taking a subset, you're picking some objects from a bigger set of objects and then arranging them. And we have a special formula for that that's called NPR. Okay, if you listen to the radio, National Public Radio, that's how I remember this. NPR, and this is the number of ways to arrange R of n objects. Or another way of saying it is the number of ways to choose R of n objects and then arrange them. Now, if we're just choosing objects and not arranging them, we have another way. That's another number. We use NCR to denote that. So NCR is the number of ways to choose R of n objects. These are here. NPR, you're counting permutations. That's what the P stands for. Here you're talking combinations. That's what the C stands for. And remember, this order does not matter. So you're just choosing n objects. So basically, you're just choosing a possible subset of size R. So this is also the number of ways you can choose R objects from a set of n objects, without regard to order. Okay. So let's say there are some nice formulas for these things. For these quantities, let's just derive them and see why this is. Here, this kind of almost does itself. This is kind of like a more general case of what we did with factorials. If we're NGR, we know if we're choosing and arranging our object well, there are n choices for the first object, or n way, I'll say just n choices for the first object as before. Then n minus 1 choices for the second object. And then finally there are going to be n minus r plus 1 choices for the rth object. Okay, and it's n minus r plus 1. It seems kind of mysterious, but it really isn't. We'll see it in a minute, but you know, it's because you can think of this as n minus 0, this is n minus 1. So you can think of this as n minus the quantity r minus 1. So there are r of these numbers here. And we just multiply them together and get this. And what this actually simplifies to a more compact form, this turns out to be n factorial divided by n minus r factorial. Or n factorial divided by n minus r factorial. I like to use this form anyway. It's a lot easier to remember, and you can see what the, you know, it just kind of makes more sense. But we'll see that you don't actually have to compute this using this formula. You can do that on your calculator, which I'll show you how to do in a moment. So then how do we find what NCR is? The number of combinations, or the number of ways just to choose R objects from a set of N objects. Well, it's basically this. We're going to compute NPR in a couple of ways. We already computed it one way. Let's say we first choose the R objects, and then we arrange them. So this is really the number of ways to choose R of N objects. So we choose them first, and then we're going to arrange them. So we multiply this by the number of ways to arrange R objects. And this, of course, this is our NCR, and this is R factorial. Okay. And so what we get, then we can see that NCR is going to be just NPR divided by R factorial, which is the same thing as saying NPR times 1 over R factorial, which is N factorial times N minus R factorial times 1 over R factorial. You're not going to have to derive this from an exam, but I want you to show you how we get this formula. Then we just multiply, switch around these factors, and we get this. All right. Now, some notes. In some special cases, we see that PNN is just the same as n factorial, because if you're choosing n of n objects, there's only one way to do that. And then it's just a matter of arranging them. So that's why this is just n factorial. There's only basically one way to choose a set with no elements. There's only one way to do that, and that subset would be the empty set. So that's why NC0 is equal to 1. And also n choose n is also going to be 1. NCN is also going to be 1, because if you have n objects and you want to pick n objects, there's only one way to do that. You take all of them, right? And in fact, we can see that n factorial, if we use the formula, we have n factorial divided by R0 factorial times n factorial. And you can see that the n factorials will cancel out. We'll just have a 1 up here. And 0 factorial is just 1. So this is just 1 over 1, which is 1. That's one reason why we define 0 factorial to be 1. NC1 is going to be just the number of ways to choose one object from a set of n objects. That should make it clear that it's n. And a more interesting formula is that NCR is always equal to n minus r. And the reason for that is whenever you take a choose a subset, you have n objects, you choose r of them. At the same time, what you have left over is a set of n minus r objects. So at the same, every time you're choosing a set of r objects, you're also choosing a set of n minus r objects. So that's why these numbers are the same. And of course, algebraically, we see that this is just this with the n minus r and the r interchanged. So that's why it's the same. One thing is sometimes I will say NCR. I'll denote that as N choose R. That's because that's what we say in other math classes. We have a special name. So sometimes, and some other times we will write this NCR instead of the C. Okay, that's the more common notation in like higher math classes. So let's just do some real simple examples here on this sheet. Number of ways to arrange 8 people on a line. Well, that would just be 8 factorial. Now, the way we can do this is we could multiply this all out, but we see that in our calculator we have a special way to do this, to do factorials. On the TI-83, I'll type 8, and we just need an exclamation point. And what we do that is we do that by hitting the math button, which is right here, and choosing the probability menu, and then you can see right down here on number 4 is exclamation point. So we choose that, and the exclamation comes up, and we get that 8 factorial is 40,320. All right, next one. The number of ways to arrange 3 people from a set of 10 people. There are a couple ways we could do this. We could see this. This is really just choosing. Well, this would be NPR. So NPR, where N is 10 and R is 3. So this would be NP3. But what this is really going to be is 10 times 9 times 8. Okay, 10 choices for the first, 9 choices for the second, 8 choices for the third, and this turns out to be 720. However, if you want to do this on your calculator, we could plug that into the formula, or we can just go and type in our first number 10, and then we want a P here, so we're going to hit the math button again, go to the probability menu, and there you can see it's NPR there, right at number 2. We'll put that there, and then we have enter 3, our number, and that is also 720. This is also 720, which is what it should be, since these are the same. Okay. All right. Now, let's say if we just the number of ways to choose 3 people from a set of 10. That means choosing means order does not matter. So this is NC3. And to find this, on our calculator, we again hit 10. Then we go to our math button, our probability menu, and there's NCR there right at number 3. And so we enter that. We enter 3, and we get 120. Okay. And interestingly, this number is always going to be less than this number because, you get more ways to do this because you're arranging them here. Here you're not arranging them. And then let's do a lottery question. So let's suppose here's a theoretical lottery where you choose 6 numbers between 1 and 50, and the order doesn't matter. Let's say the computer just automatically puts them in increasing order, let's say. How many different tickets are possible? Well, you're choosing 6 from a set of 50, so the answer would be 50 C6. Okay. So we do this, we hit 50, math, probability, 6, and we get 15,890,700. And of course, what this means is the probability of winning is approximately 1 over 16 million. That's what this is. Okay, so that's how bad your odds are. Of course, all odds are bad in lotteries. And in fact, that's just with 50 numbers. Most of them you have 70 numbers to choose from, and you can imagine how much worse that is. So, all right. So we'll do some more examples in the next video. See you then.